Hello everyone, myself Deepak Upadhyay from Impulse Technology, Gurgaon, Delhi. In this video, I will show you how to calculate the effective carrier mass in silicon material by using NanoDCAL software. So let's get started. This is my device studio that is called graphical user interface, and that will help you to model the structure. You can do some modification, manipulation in your atomic structure, device structure as well. So first I would like to import the silicon material from my local database. So for this you can select this file option, go to the import option and select this import local. And here you can see this is the material database that exists inside this software. So for silicon you can click on this 3D material, select this semiconductor, and here you can select this silicon and then you can click on this open. So here you can see this is the silicon that I have imported from my local database. And if you want to simulate this silicon, so you can go to the simulator, select this NanoDCAL and select this self-consistent field calculation. So this is the self-consistent field calculation parameters. So here you can see this is the basic setting: electron temperature, cutoff energy, exchange correlation, LDA, GGA. This is the K point sampling. This is the iteration control, density matrix, Hamilton matrix, total energy, and this is the basic settings. And this is the spin type, like collinear spin, general spin is there. So I am taking the default parameter and then I would like to click on generate file. So once you click on this generate file, in the project window you can see the SCF input for this silicon has been generated. So you can select this scf.input, right click and click on open with. And you can see this is the script that automatically generated once you click on this generate file. Here you can see what parameter we have defined. This is the basic setting: electron temperature, cutoff energy, exchange correlation. And here you can see no spin is included, and this is the iteration control, and this is the basic settings, atom and their Cartesian coordinate point. So then you can select this SCF input, right click, run option to run this job. Here you can see, suppose if you want to run this job on parallel, suppose 5 core, 10 core, 15 core, so there is no limitation of core, you can define up to 128 core. Then you can click on this run option to run this job. In the bottom of the page you can see this is the job manager where the SCF input is in the running condition, and in the meantime you can go to the simulator, select this NanoDCAL, then you can select this analysis. Here you can see this is the analysis parameter, so you can select what parameter you want to calculate. So I would like to select this effective mass, and in the first cell you can see this is for the holes and electrons. The -1 is for the valence and -2 is for the second valence band, and 1 is for the conduction band and 2 is for the second conduction band, and this is 1 is for the spin up and 2 is for the spin down. And here you can see this is the K point sampling. Then you can click on this generate file. So similarly you can run this effective mass.input file. And if you want to calculate the complex band structure, so again you can go to the simulator, select this NanoDCAL and go to the analysis, and here you can select this complex band structure. And here you can see this is the space grid number n1, n2, n3, and this is the number of energy point, and this is the energy range. Then you can click on this generate file, and similarly you can run this complex band structure .input file. So you can wait till the calculation finished. Once their calculation finished, their output will be generated. In the job manager you can see all the input calculation has been finished and their output has been generated. Here you can see this is the complex band structure.xml file. Select this complex band structure, right click and click on show view. Here you can see this is the complex band structure. For the effective mass output file you can select this log file, click on open containing folder, and here you can see this is the effective mass.mat file, and this file will open in the MATLAB. So I would like to open my MATLAB. So from browse option you can upload your project folder in the MATLAB. You can see this is my project effective mass, and then you can click on select folder. Here you can see this is the effective mass.mat file. So double click on this effective mass.mat file to load this project, and here you need to write the command data and then press the enter. If you want to show the effective mass output file, so you can write the command and then you can press the enter. And if you want to show the output of mass longitudinal, transversal, then you can write the command. So for the mass longitudinal you can write this command and then you can press the enter, and this is the output for this mass longitudinal. And if you want to show for the mass transversal, so again you can write the command and then you can press the enter, and here you can see this is the output for this mass transversal. So thank you for watching the video.